part about this is if two angles are vertical, then they are congruent. The question is, do you think it's biconditional? Talk to your partner. Do you think the vertical angle theorem is biconditional? So the converse is going to be, if I have two angles that are congruent, are they vertical? Can anybody describe to me or draw to me congruent angles that are not vertical? Okay, right before the lunch bell rang, we were starting off by talking about these theorems, and what's really cool, the way that Euclid set up our program is definitions precise, postulates given, let's have as few of them as we possibly can, but we can use those with our properties to prove as many theorems as we possibly can. So we've been talking about vertical angles, and you've probably been wondering, why is this now a theorem when we've had vertical angles and we've known that they're congruent? So this conversation shouldn't really feel very new, but now all of a sudden it's a theorem. When we talked about what the definition of a vertical angle is, it never told us that it was congruent. It just told us what they were. When we write it as a conditional statement, if two angles are vertical, then they're congruent, I don't think that they're biconditional at all. Because in my mind, if I have two congruent angles, let's say I know an angle is bisected, and somebody tells me that those two angles are congruent, they're definitely not vertical. So it's not a biconditional situation like we were with our definitions and our postulates. One big difference about theorems. So it's interesting if I want to talk about how I could prove this theorem, what I might want to do is, okay, let's go ahead and clear up some of this. And how could we go ahead and prove that angles 1 and 3 and 2 and 4 are congruent, given what we know? And we have to go back to those postulates that we do understand. And the first one we're going to think about is our linear pair postulate. The linear pair postulate says if you have two angles that are a linear pair, I do, I'll just pick angle 2 and angle 3, then we know that they are supplementary. Oh, okay. So that means that the measure of angle 2 plus the measure of angle 3 is equal to 180. How is that going to get me to congruent angles? Turn to your partner and ask them, do you have any ideas? Ask them. Well, let me ask you this. Any other angle pairs add up to 180? Are there any other angle pairs that add up to 180 degrees? Sebastian says yes. Which ones? So Sebastian says the measure of angle 3 plus the measure of angle 4 is also equal to 180 degrees. So he's talking about 3 and 4 being a linear pair. Do you see how these are both equal to 180 degrees? Anybody have any big ideas? What if I said the measure of angle 2 plus the measure of angle 3 is the same as the measure of angle 3 plus the measure of angle 4? Who says I can do that? Who says I can do that? Transitive property of equality? Maybe substitution property of equality? They would both be justifiable reasons. Hey, what if I now wanted to say, if I subtract the measure of angle 3 from both sides, the measure of angle 2 is going to be equal to the measure of angle 4. Come on. Check it out. Measure of angle 2 is congruent to measure of angle 4. How could I get 1 and 3 equal to each other? Turn your partner, ask them. How can we do this for angle 1 and angle 3? Go. One and 3 equal to each other? How you doing? Come up with any ideas? 1 and 3 equal to each other? Anybody have an idea? So we'll go back and we'll talk again about our picture. We talked about 2 and 3 and 3 and 4. If I want to figure out how 1 and 3 can be congruent to each other, what if I talk about, I don't know, 1 and 2 being a linear pair, 2 and 3 being a linear pair, and then subtracting angle 2 from each of those conversations. So what I need you to start doing is looking at each of these theorems and think, wait, what do I already know that can help prove this? Our definition of supplementary helped us. Our properties helped us. Our linear pair postulate helped us. Linear pair postulate, definition of supplementary, substitution, and subtraction. So I need your head starting to spin with all these different ideas. All right, let's talk about our congruent supplements theorem. Our congruent supplements theorem says if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. All right, let's say that angle 3 and angle 1 are supplementary. Angle 3 and angle 2 are supplementary. If two angles are supplements of the same angle, then those two angles are congruent. Hey, I want you to rewrite that congruent supplements theorem using symbols. Turn to your partner and go. All right, what this says in symbols, is if the measure of angle, if two angles are supplements to the same angle. So if measure of angle 3, well, let's not have the measure, let's just have the angle. If angle 1 and angle 3 are supplementary, and angles 2 and angle 3 are supplementary, make sure that looks like a 3. Then angle 1 is congruent to angle 2. So now that we're using our past definitions and big ideas to prove these, turn to your partner and think about how could you prove this. Look what we did above and see what you can do. And hey, I gotta tell you something, you got a choice. You can sit back and passively wait for us to do it for you and not learn it. Or you could lean in, talk to your partner and say, let's go, let's figure this out. What is she asking us to do? Go. So this is what we're working towards. Definition of supplementary. Said excuse me, ladies. Thanks. Definition of supplementary, that means their sum is 180 degrees. Okay? So that's this big idea that I have here. What does it mean to be supplementary? Here we go. Definition of supplementary. Their angle measures at 180 degrees. Hey, if they're both equal to 180 degrees, then I can substitute one in for the other. This also fits the transit property of equality. Sometimes there's more than one justification. And then I subtract the angle 3 from each side, and that leaves me with the measure of angle 1 is equal to the measure of angle 2. Boom, definition of congruence. They're congruent. I'm listening to these two gents talk, and they're like, I get it once she says it, but I can't remember all these things. There's a lot to keep track of so far. They have the perfect perfect lead into what we're going to talk about next. All right, congruent complements theorem. What is the difference between what we just did and this one? Congruent complements theorem. Now what? It's complementary. What's the difference? 90 degrees. It's 90 degrees. So if I have rewriting this using symbols, I can say if the measure of angle 1 plus the measure of angle 2 equals 90 degrees, and the measure of angle 3 plus the measure of angle 2 is equal to 90 degrees, then the measure of angle 1 is equal to the measure of angle 3. I want you to pay attention to something. Look at the difference between what we talked about. Congruent supplements I wrote as congruent angles. Congruent complements I wrote as equal angles. Think about the definition of congruence. Whether I'm talking about things or angles, they can be written either way. How could you prove this theorem? same as what you did up here, except for now, they're equal to 90 degrees. And you could go ahead and set these two guys equal to each other. Subtract angle 2. You have 1 and 3 congruent to each other. All right, here's our next up. Our right angle theorems. This is the theorem that says all right angles are congruent. So if measure of angle 1 is equal to 90 degrees, and the measure of angle 2 is equal to 90 degrees, then angle 1 is congruent to angle 2. Definition of congruence. If two angles are supplementary and congruent, then each is a right angle. Think for a minute, how would I prove that? If they're supplementary angles when added together equal what? 180 degrees. If they're congruent, they both have the same value. So this x and this x, so 2x is equal to 180 degrees, therefore both those angles have to be right angles. So every time we're given a theorem, our brains should go nuts. Zoom, spinning. How could I prove this? What do I already know? Here's the hard part. All of the things that we've learned in the past are still kind of in our brains, but not really guaranteed to be there, which is why we're going to give you what we're calling a proof pantry. So I want you to imagine your mom or dad, whoever the cook is in your house, brother, sister, trying to decide what's for dinner, and they're stuck, they're out of ideas. I do this all the time. Anybody else ever see their parents just walking into the pantry and staring? So I'll go into my pantry and I'll look and see what I have. I've got some taco shells. I've got some taco seasoning. I've got some corn chips. I've got some salsa. I'll go into the fridge. I've got some ground beef and some cheddar cheese. What am I thinking of making for dinner? Maybe some nachos. What else? Tacos. Maybe some tacos. Okay? Now, I get ideas when I walk into the pantry. Somebody said, what do you want? What do you want for dinner? I'm not sure I would have come up with tacos, but once I go look at the chips and the taco shells and the seasoning and the salsa, and I'm like, oh, let's have nachos. Let's have tacos. Now, guess what else is inside the pantry? Coconut milk. Am I putting that in my tacos? No. There's soy sauce in there. There's spaghetti sauce and pasta, a couple potatoes. Any of that going in my tacos? And Charlotte says, I hope not. Sound like some pretty nasty tacos to me, right? So what we're going to do and spending the rest of today looking at is what options do I have for using in my proofs? So far, you've had a lot of notes. And here's the back of notes 2.5 that has us using these angle theorems and a proof that includes these justifications. Well, these guys are up here saying the exact perfect thing. I don't remember everything we've learned. It's not sticking in the front of my brain. I gave you this homework, and we talked about this proof before the test. But I told you to look at the back of this, and here's some angle proofs. And you're like, I don't feel like I could fill them out because I don't know what we have. So now enters our proof pantry. What we're going to do is you and your partner are going to page back through your old Unit 1 and Unit 2 notes, and you're going to make a list of the different properties, definitions, and postulates, along with rules of logic, because that's what ends up helping us build our theorems. We just spent some time proving our vertical angles theorem. And when we did that, we did the linear pair postulate. We used the definition of supplementary, and we used the definition of congruence. We subtracted the same angle from each side. We substituted, and we also used the transitive property of equality. So we use those properties, these definitions, to prove the vertical angles theorem. So what I want you to do is start making a list of what's in your pantry. What have we learned? What's a possible reason, justification, definition, property, or postulate that you have out there? Now, we're not going to try to stay so organized that we can keep track of everything on how we proved it. We just want to listen. We just want a list. If you don't know what LPP stands for, you write out linear pair postulate. If you don't know what VA theorem stands for, you write out vertical angles. Because what we want is a list of everything, because I got to tell you, now that we have proven this, we can use it. Here's your homework for tonight. Let me finish, please. Go through your notes, fill out your proof pantry, and do the back of notes 2-5. Got it? All right.